Okay, so now that our SAS software is all set, let's get started. In a nutshell, statistics is all about converting data into useful information. We do that for the purpose of creating new knowledge. The process of statistics really starts when we identify what group we want to study or learn about. We call this group the population. This word population is not just used to refer to people. It's used in a broader statistical sense, where population can refer not only to people, but also to animals, things, etc. For example, we might be interested in the opinions of the population of U.S. adults about the death penalty, or maybe how the population of caterpillars react to different diets, or even the average price of the population of all one-bedroom apartments in a certain city. Population, then, is the entire group that is the target of our interest. In most cases, the population is so large that as much as we want to, there's absolutely no way that we can study all of it. Imagine, for example, trying to get the opinions of all U.S. adults about the death penalty. A more practical approach is to examine and collect data only from a subgroup of the population, which we'll call the sample. Since for practical reasons we need to compromise and examine only a subgroup of the population rather than the whole population, we should of course choose a sample in such a way that it will represent the population well. But what do we really mean by data? Put simply, data are pieces of information about individuals organized into variables. By an individual, we mean a particular person, object, or any other type of observation, even a location such as a city or a country. By a variable, we mean a particular characteristic of the observation. At the person level, we might collect data on height, weight, gender, race, etc. If we are collecting data on a sample of cars, we might measure variables such as its color, mileage, model, maybe number of seats. If our sample includes cities, we might measure variables such as population size, tax revenue, energy consumption, number of hospitals. A data set is literally a set of data, that is, observations and variables. Data sets are typically displayed in tables, in which rows represent individuals or observations and columns represent variables. Here I have a data set that shows medical records from a survey. In this example, the observations are patients and the variables are gender, age, weight, height, smoking, and race. Each row then gives us all the information about a particular observation, in this case a patient, and each column gives us information about a particular characteristic of all the patients. Variables can also be classified into one of two types, quantitative or categorical. Quantitative variables take numerical values and represent some kind of measurement. Categorical variables, on the other hand, take category or label values and place an individual into one of several groups. In this example, there are several variables of each type. Age, weight, and height are quantitative variables. Race, gender, and smoking are categorical variables. Notice that the values of the categorical variable smoking has been coded as numbers, 0 or 1. It's quite common to code the values of a categorical variable as numbers, but you should remember that these are only codes, often referred to as dummy codes because they have no arithmetic meaning. That is, it doesn't make sense to add them, subtract them, multiply, divide them, or even compare the magnitude of these values. Finally, a unique identifier is a variable that is meant to distinctively define each of the observations of your data set. Examples might include serial numbers for data on a particular product, social security numbers for data on an individual person, or maybe random numbers generated for any type of observation. Every data set should have a variable that uniquely identifies the observations. This variable is particularly useful if you ever need to merge information across different data sets. In our example, the patient number, 1 through 75, is the unique identifier. So by relying on data sets, statistics pulls all of the behavioral, physical, and social sciences together. It's arguably the one language that we all have in common. While you may think that data is very, very different from discipline to discipline, it really isn't. What you measure is different, and your research question is obviously dramatically different. Whom you observe and whom you collect data from, or what you collect data from, can be very different. But once you have the data, approaches to analyzing it statistically are often quite similar across many different disciplines. Since we will not actually be producing data in this course, your first step will be to choose a data set that offers the opportunity to conduct research on a topic of interest to you. The data sets that I've made available include the following. First is a portion of the Wave 1 National Longitudinal Study of Adolescent Health, or AdHealth. This is a nationally representative school-based survey of adolescents in grades 7 through 12 in the United States. AdHealth includes survey data on social, economic, psychological, and physical well-being of adolescents. Next is the Mars Crater Study. As you may know, the planet Mars has terrain that is heavily cratered. These craters were created about 4 billion years ago during a period of heavy bombardment from asteroids, protoplanets, and comets. Made available by researchers at the University of Colorado Boulder, this data set includes characteristics of more than 350,000 of these Mars craters. Also available is a portion of the National Epidemiologic Study of Alcohol and Related Conditions, known as the NESARC. This is a representative sample of the U.S. adult population age 18 and older, and it includes data on mental health and substance use disorders that are experienced by adults. Finally, the Gapminders dataset, which is made available by gapminder.org, includes numerous measures from 195 countries. The data have been collected from various sources, including the World Health Organization, the International Agency for Research on Cancer, the United Nations, and the World Bank. Now, before accessing any data, you will be reviewing the available codebooks from these datasets. Sometimes called data dictionaries, codebooks commonly offer complete information regarding a dataset. That is, general topics addressed, questions and/or measurements used to record each of the variables, and in some cases, the frequency of responses or values of each of the variables. Reviewing a codebook is always the first step in research based on existing data. First of all, codebooks can be used to generate research questions, and secondly, data is often useless and uninterpretable without them. The codebook describes how the data are arranged in the computer file, what the various numbers and letters mean, and any special instructions on how to use the data properly. Like any other book, some codebooks are better than others. Here I have an example from the AdHealth codebook. For each of the variables, you have the description of the variable that is measured. In this case, it's the question, what grade are you in? A codebook will also include the various measurement or response options. So here you can see that possible response options include 7th through 12th grade, refusal to answer the question, a legitimate skip for those not in school, don't know, and the school does not have the grade levels, or the question is not applicable. Aside from including a listing or description of the response options for the variable, the codebook will also include corresponding values that can be found in the dataset. As we saw previously with the medical records dataset example, datasets typically include numbers rather than words. So for categorical variables such as grade level, each of the response options has a corresponding numeric value, and it is that numeric value that can be found in the dataset. You can see that 7th through 12th grade are logically coded as the numbers 7 through 12. 96 indicates that the adolescent refused to answer. 97 indicates a legitimate skip for the adolescents who are not currently in school. 98 indicates don't know, and 99 is recorded in a case where the school does not have grade levels. These numeric values, again, are known as dummy codes, as they are included in the dataset but carry no direct numeric meaning. Here is an excerpt from the Mars Crater Codebook. It includes a description of the variables for the crater's name, latitude, longitude, and diameter, and also the depth of the crater's rim, as well as the variable's name in the dataset. Because most of these are quantitative variables, rather than listing response options, the codebook includes a description of how the variable was measured. For example, latitude is measured in decimal degrees north, longitude is measured in decimal degrees east, and both diameter and depth are measured in kilometers. From the Gapminder dataset, we see a slightly different look to the codebook, but very similar features. You can see that the middle column describes each of the variables. The column on the left indicates the variable name used in the dataset, and finally the right-hand column lists the source of the data. Again, because these are quantitative variables, the codebook includes information on how each of these variables were measured. You can see that income per person is measured in US dollars. Alcohol consumption is measured in liters of pure alcohol. Armed forces is measured as the percent of the total labor force. And finally, breast cancer rate is measured as new cases per 100,000 females. So now you have a general feel for datasets, variable types, and codebooks. And at this point, we're ready to start assignment 1. A first step is to select one of the 4 datasets, AdHealth, Mars Craters, NESARC, or Gapminder for use during the course. After selecting your dataset, you should print the corresponding codebook for your own use. You'll be relying on this extensively. And second, identify a specific topic of interest and highlight or circle the variable or variables that measure your selected topic. In the example that I will be working through, I chose the NESARC dataset. After reading through the codebook for the NESARC study, I decided that I'm particularly interested in nicotine dependence. This is represented in the dataset by a few variables. Here I show two of them, lifetime nicotine dependence and nicotine dependence in the past 12 months. A value of 0 for each of these variables indicates no nicotine dependence, and a value of 1 indicates the presence of nicotine dependence. I also note that the name of these variables are tab12mdx and tablifedx. I'll use these names later when we begin to work with the data. Once you have a topic, it's time to build a research question. And one of the simplest research questions that can be asked is whether two topics are associated with one another. For example, is medical treatment seeking associated with income? Is humidity associated with caterpillar reproduction? Is water fluorination associated with number of cavities during dentist visits? While nicotine dependence is a good starting point for me, I need to determine what it is about nicotine dependence that I'm interested in. It strikes me that friends and acquaintances that I've known through the years that became hooked on cigarettes did so across very different periods of time. Some seem to be dependent and smoking heavily soon after their first few experiences with smoking, and others after many years of generally irregular smoking behavior. I decide that I am most interested in exploring the association between level of smoking and nicotine dependence. I believe that they are positively associated. That is, the more an individual smokes, the more likely they are to be nicotine dependent. And I'm also wondering how much a person needs to smoke to be nicotine dependent. So identify the variables that measure this second topic in the NESARC data. These include cigarette smoking status, usual frequency, and usual quantity. During your second review of your codebook, you should also identify a second topic that you'd like to explore in terms of its association with your original topic. And again, highlight or circle the variable or variables that measure this second topic. At this point, you have a great start to your research project and you're ready to submit assignment 1.